Hey Ravens! Today we are going to use systems of equations substitution to solve when both equations are in standard form. This is the first time I'm using PowerPoint to screen record, and I'm using a stylus, so I might mess up a little bit, but just go along with it. I am trying my best like all of us are. This lesson happens to match 5-3 in the book. This is example 1. It's page 272 if you want to try and follow along. Now, when you go to that page, it looks like this. And it's a word problem. So what we're asking you to do is not to be able to write an equation from a word problem. It's to solve a systems of equation using substitution when both equations are in standard form. I know there's no equations here. I'm going to write this equation set for you based on the word problem. There's also instructions on how to do this in your textbook. But remember, that's not the skill we're looking for. We're simply looking for, can you solve it? So I'll let you know when you have to start writing down the skill here. So this says, Gemma sells tickets at a local fair. On Saturday, she sells 800 tickets and collects a total of $7,680. How can Gemma determine the number of each type of ticket that was sold on Saturday? This is a pretty common systems of equation question written in standard form. And as you can see here, we have the price of tickets right here. And so we have adults are $13.50 and children under 12 are $7.50. So the way that I like to think about equations like this is, I know it's a system and I know it's going to be two different equations, so I'm going to break it down in my head like this. The first equation is going to be about tickets. It's going to be the amount of child tickets plus the amount of adult tickets equaling total tickets. The second equation is going to be about money. So it's price per child ticket and price per adult ticket and then the total money. So let's see what this word problem is giving us. So we know that we have to figure out how many tickets. We're determining the type of each ticket, and we know there's 800 tickets. So we know there's 800 tickets total. And then we know that we have our prices here. So adults equal $13.50 and children are equal to $7.50. So let's see what we can do with this information to write some equations that work for us. So the amount of child tickets and the amount of adult tickets is actually the information we're looking for. We only know the total amount of tickets is 800. So when we don't know something, we can substitute a letter in until we know it. So for the amount of child tickets, I would normally use X here, but the book is using C, so I'm going to say C, and then the amount of adult tickets we'll just say is A. So that means some amount of child tickets plus some amount of adult tickets equal 800 tickets total. If it makes it easier for you in your head, you can always say one child ticket plus one adult ticket. Instead of leaving C and A, you can put a coefficient of 1. The second equation should be about money. So if we remember, a child's ticket costs $7.50 per child's ticket, and then the adult ticket costs $13.50 per adult ticket. And the reason I'm sticking the C and the A next to the numbers is because it's $7.50 times the amount of child tickets plus $13.50 times the amount of adult tickets. And then, of course, our total amount of money we earn is from selling tickets is $7,680. All right, so again, our first equation is just going to be about the amount of tickets, and the second is about money. And together we have a system of equations that we can manipulate to solve this. So this is where I want you to start learning the skill here. If you are given a set of equations, C plus A equals 800, and then 7.5C plus 13.5A equals 7680, how are you going to figure out what C and A equal? So this is essentially the same thing as saying X plus Y is equal to 800 and 7.5X plus 13.5Y is equal to 7,680. But we're going to go ahead and just use C and A for this. So we need to in order to solve this equation, manipulate one of the equations so that we have one variable on one side and then something we can work with on the other side to substitute. So I'm going to go ahead and just start with c plus a equals 800 here, and I have c plus a equals 800. Well, I know that I can get c alone by subtracting a because a has been added to c. And if I do that, I can get c is equal to 800 minus a. So now that I have something that's equal to c, I can go ahead and just take this and plug it into this part of the equation here. So let's go ahead and do that. I have, as we recall from the page before, we have c equals 800 minus a. So now I'm going to go ahead and take my additional equation here, 7.50, and instead of c, I'm going to put in 800 minus a, and then I'm going to write the rest of my equation plus 1350a equals 7,680. So now I have just a that I need to solve, and it becomes essentially a two-step equation with distributive property. So this should look more and more familiar to you guys. So I need to take 750 and distribute it through the quantity of 800 minus a. So I'm going to go ahead and take this, and I need to do 7.5 times 800, and that becomes 6,000. And I'm going to go ahead and put a plus here because when we multiply 7.5 to this a, it's actually multiplying it to the negative a. So 7.5 times negative a is going to be negative 7.5a. And then I'm going to go ahead and bring down this plus 13.50a is equal to 7,680. All right, so now the next step in any two-step equation or multi-step equation is combining like terms. So I have 6,000 here plus negative 7.5a plus 1350a. And this is the same thing as 7.50a. I can see here that I have like terms. I have this negative 7.50a and I have a positive 13.50a, so I can combine those two to be 13.5 minus 7.5 is going to be 6a. And then I'm going to bring down the 6,000 and then equals 7,680. And now I just have a basic two-step equation. So I want to get this a alone. I got to go ahead and go backwards. A has been multiplied by 6, and then 6,000 was added, and it equals 7,680. I'm going to go ahead and go backwards. Subtract this 6,000, and I have 6a is equal to 1680, and I'm running out of space, so I'm going to go to the next slide. So as a reminder, I had 6a is equal to 1680. I'm just trying to figure out what a is, so I'm going to divide both sides by 6. A is equal to 280. So that was a huge ride to get where we got. A is 280. So what does that mean? That means that right here, the amount of adult tickets is 280 adult tickets. And then we have to figure out what C is, and then we know that it's 800 tickets. So we can go ahead and actually just say the amount of child tickets is still unknown. The amount of adult tickets is 280. And the total amount of tickets is 800. So how are we going to figure out how many child tickets were sold? Well, we subtract 280 here, subtract 280 here, and we end up having 520 tickets. So 520 tickets plus 280 tickets. Does that add up to 800 tickets? It does. So we know that the child amount of tickets was 520, and we know that the adult tickets was 280. So our answer here is going to be child 520, adult 280, and that is our answer for this problem.